Okay, we start now for the flat belts design in machine design 2. This is the flat belt with pulleys. So ang belt ito lang, sinturon na flat. Introduction. The belts are used to transmit power from one shaft to another by means of pulleys, which rotate at the same speed or different speed. So ito, different speed kasi mag-iba yung size ng pulley niya. So the amount of power transmitted depends upon the following factors. One is the velocity of the belt. Then two, the tension under which the belt is placed on the pulley. And the arc three, the arc of contact between the belt and the smaller pulley. And four, the conditions under which the belt is used, environmental, is an ambient. Kung madumi, malikabok, so siyempre, yun na yung belt mo. Selection of belt drive. Following are the various important factors upon which the selection of a belt drive depends. The speed of the driving and driven shaft, the speed reduction ratio, power to be transmitted, center distance between the shafts, so kailangan yun. Kasi yung dyan naman complete yung length ng belt. So, positive drive requirements, shaft layout, space available, and service conditions. Types of belt drives. So the belt drives usually classified into the following groups. Mayroong light drives. These are used to transmit small powers at belt speed of up to about 10 meters per second, as in agricultural machine and small machine. Next is medium drive. These are used to transmit medium power at belt speed over 10 meters per second, but up to 22 meters per second, as in machine tools. So, bilis na to. Then, ito yung pinakamabilis. So, heavy drives. These are used to transmit large power at belt speed above 22 meters per second, as in compressors and generator. Ito yung mga types of belts na ginagamit. Though there are many types of belt used these days, yet the following are important from the scientific point of view. Meron tayong flat belt. So the flat belt, as shown in figure 1A, is mostly used in factories and workshop, where a moderate amount of power is to be transmitted from one pulley to another when the two pulleys are not more than 8 meters apart. So, pag mahaba na haba ng belt ko yung saging niya. Next is the B-belt. The B-belt, as shown in figure 1B, ito is mostly used in the factories in workshop, where a great amount of power is to be transmitted from one pulley to another when two pulleys are very near each other. Okay. Ano kasing mali B-belt. Next, circular belt or loop. The circular belt or loop, as shown in figure 1C, is mostly used in factories and workshop, where a great amount of power is to be transmitted from one pulley to another when the two pulleys are more than 8 meters apart. So, yeah. Ang topic natin una is about flat belt. So, what is the material or are the materials used for belts? Mayroong leather belts. Diba? Leather. The most important material for flat belt is leather. The best leather belts are made from 1.2 meters to 1.5 meters long strip cut from either side of the backbone of the top grade steel hides. The hair side of the leather is smoother and harder than the flesh side, but the flesh side is stronger. The hair side and the lateral motion. Single layer. The fibers on the hair side are perpendicular to the surface, while those on the flesh side are interwoven in parallel to the surface. Therefore, for this reason, the hair side of a belt should be in contact with the polished surface as in figure 2. Yan. So, single layer, ito yung naman ng double layer. Cotton or fabric belts. Tayo dito example. So, most of the fabric belts are made by folding canvas or cotton duck to 3 or more layers, depending upon the thickness desired. and it teaches stitching together yung mga canvas type. These belts are woven also into a strip of the desired width and thickness. Okay. Rubber belt. Instead of leather, rubber. The rubber belts are made of layers of fabric impregnated with rubber composition and have a thin layer of rubber on the faces. These belts are very flexible but are quickly destroyed if allowed to come in contact with heat, oil, or grease. Next, the balata belts. These belts are similar to rubber belts except that balata gum is used in place of rubber. These belts are acid-proof and waterproof and it is not affected by animal oils or alkalis. The balata belts should not be at temperatures above 1 dC because at this temperature the balata begins to soften and becomes sticky. The strength of balata belts is 25% higher than the rubber belts. Next is the working stresses in belts. The breaking strength of oak-tan belting varies from 3 to more than 6 KSI. Oak-tan. Mineral tan leather is stronger, say 7 to 12 KSI in breaking strength. To make the belt inless, the ends must be joined by cementing, so yung factor is 1.0. By wire lacing with machine, factor is 0.88. Reduction factor by metal hooks is 0.35. And by other metal, where N is the relative strength of the joint. And the ultimate strength of middle belt varies from 21 to 35 megapascal, and a factor of safety may be taken as 8 to 10. However, the wear life of a belt is more important than the actual strength. It has been shown by experience that under average conditions, an allowable stress of 2.8 megapascal or less will give the suitable belt type. An allowable stress of 1.71 megapascal may be expected to give a belt type of about 15 years. For normal good operating conditions and Pulley sizes larger than the minimums, and the design stress of segment D as 400 times the relative strength of the joint should result in a belt capable of satisfactory life. Ito yung mga density of belt material. Yan. Sa material of belt, leather, the mass density is 1,000. Canvas, 1,220. Rubber, 1,140. Balata, 1,110. Single woven belt, 1,170. Double woven belt, 1,250 kilogram per cubic meter. Belt speed. Experience suggests that the most economical speed are obtained for a belt of 4,000 to 4,500 feet per minute or 20 to 22.5 meters per second. But of course, any particular application may require some other speed. For leather, a speed of 7,000 to 8,000 feet per minute are in use, but consult the vendor. Flat fabric belts operate up to 20,000 feet per minute and more. On high speed centrifugal blower, it has been observed that the arc of contact data is reduced from 180 degrees at rest to 110 degrees in motion. One of the side effects of the speed. Coefficient of friction between belt and pulley. Yun, contact kasi yun. The coefficient of friction between belt and pulley depends upon the following factors: the material of belt, the material of pulley, the strip of pulley, and the speed of pulley. So according to C.G. Bars, the coefficient of friction F for oak-tan leather belts of cast iron pulley at the point of steeping is given by the following relation: F is equal to 0.54 minus 42.6 divided by 1 from 2.6 plus B, where B is the speed of the belt and meters per minute. So the following value shows the value, following table shows the value of coefficient of friction for various materials of belt, other belt. Diba? Kaya na oak-tan. Ito yung mga value niya. Belt material, meron pulley material mo, cast iron, ito dry wet greasy, wood, compressed paper, leather face, and rubber face. Yung mga value. Then from pairs, ito rin. The coefficient of friction varies with the amount of slip. A part of total slip is scrape. which exists because the driving pulley receives a longer stretched belt than it delivers, and then ribbon receives a shorter belt than it delivers, giving rise to relative motion between the belt and the pulley. As the total slip increases, the compression of friction, figure T, 2% slip is satisfactory for needle on steel or iron. For normal design conditions for flat belt, use the following. Needle on iron or steel is F.3. Needle on paper polish, F is 0.5. Standard belt thicknesses and widths. Ito yung mga standard flat belt thicknesses, which are 5, 6.5, 8, 10, and 12 mm. So the preferred value of thicknesses are as follows: 5 mm for nominal belt width of 35 to 60 mm, 6.5 mm for nominal belt width of 50 to 140 mm. Guide lang to, guide. 8 mm for nominal belt width of 90 to 224 mm, 10 mm for nominal belt width of 125 to 400 mm, 12 mm for nominal belt width with 250 to 600 mm. These the standard values of nominal belt widths are R10 series starting from 25 up to 63 mm, and R20 series starting from 71 up to 600 mm. Thus, the standard widths will be 25, 32, 40, 50, 63, 71, 80, 90, 100, 112, 112.5, 140, 160, 170, 180, 200, 224, 250, 280, 315, 355, 400, 450, 500, 560, and 600. In English units, let the standard width be as follows. So by width, the width varies by 1/8 increment from 1 up to 1 inch, by 1/4 inch increment from 1 to 4, by 1/2 increment from 4 to 7, by 1 inch increment from 7 to 12. Larger sizes are obtained by special order. Single leader belt should be specified in width not over 8 inches because this represents about the maximum width of suitable leader that can be cut from behind. So, ibig sabihin itong by 1/4, increment from 1 to 3. Sabihin, 1 in 1/4, 1 in 1/2, 1 in 3/4, 2 inch. Next, and so on. Belt joints. When the endless belts are not available, then the belts are cut from big rolls and the ends are joined together by fastener. So the various types of joints are cemented joints, that's picture A, lace joint, and hinge joints. Yeah. Cemented joint as shown in figure 4A, made by manufacturer to form and is preferred than other joints. The lace joint is formed by punching holes in the of the belt, leaving a margin between the ends and the holes. A rawhide strip is used for lacing and the two ends together to form a joint. This type of joint is known as a straight stitch rawhide lace joint, as shown in figure 4. And last, metal lace joint is shown in figure C. Is made like a staple connection. The points are driven to the flesh side of the belt, included on the inside. Sometimes metal hinges will be fastened to the belt and connected by steel or fiberglass pin. Yeah. Efficiencies of belt joints are ito siya. Pagdabayan mo. Now for the for open belt drive, na-discuss na ito sa machine element yun, di ba? For the length of open belt drive, so ito yung figure mo, ito yung figure is yung exact equation. This is yung gamitin natin is yung approximation, which is the length is approximately 2C plus 1.57 times D2 plus D1 plus D2 minus D1 squared over 4C. Take note, the 1.57 is pi over 2. So you can use pi over 2. Kung nag-pi over 2 kayo, yung calculator nyo, gamitin is pi. Hindi, is 1.57. Huwag yung ilalagay na 5/2 tapos kinakalculator nyo is 1.57. Huwag yun. Kasi mag-check na pag-check ng value, iba ang lumalabas sa calculation niya. Where C is the center distance, D2 is the diameter of the larger pulley, and D1 is the diameter of the smaller pulley. Kaya nga ito minus. So dito minus D1. So dito is greater than 1. Totally pag nakalagay nyo pi, pag nakalagay is pi, so that is calculator nyo is pi. Huwag nyo gagamitin na nakasimbol nyo is pi. Ginagamit na 3.14. Imaginary, nasa isip nyo lang yung 3.14 divided by 2, 1.57. Pero nakalagay sa dito mo is pi over 2. So ako mag-check naman nag-check, gagamitin ko pi over 2. Okay? So lalabas, mali ang sagot niya. Dalawang klase yung installation ng belt line. Sa flat belt lang to. Meron tayong isa pa, cross belt. So the length of cross belt line is approximately 2C plus 1.57 times D2 plus D1 plus D2 plus D1 is equal to 4C. So same symbol. Next, angle of contact. Ito. Yan. Ito. Angle of contact niya. Ito ganun din. Sa cross belt, they are the same. For open belt drive, the angle of contact are theta is equal to pi plus or minus 2 times arc sine of R1 minus R over C, or approximately as pi or plus 1 over plus or minus D2 minus D1 over C. So kaya gamitin nyo dito, this is in radians. Use the plus signs for the larger pulley and minus sign for the smaller pulley. Next, the cross belt. The angle of contact are the same on both pulleys. So theta is equal to pi plus 2 times arc sine of R plus R over C radians. Take note na dito hindi siya gumamit ng D2 plus D1 over C na walang arc sine. Bakit? Kasi plus to. So hindi mo siya pwedeng i-approximate. Ito minus, liliit pa to. Alam niyo naman yung approximation, di ba? Yung ano niya? Sa mga small numbers. So, dito hindi siya small. So hindi ka pwedeng gumamit pa. Okay? Hindi mo pwedeng gamitin pi plus D2 plus D1 over C. So hindi pwede yun. Ang layo ng sagot na. Okay? Where R is the radius. D2 of the larger pulley, small letter r is the radius of the smaller pulley. C, the distance between the pulley, and theta, the angle of contact in radians. In general, the sine equation use the minimum value of f theta, which is the smaller pulley when the pulley are of same material. So pag different material siya, both kukunin mo, tapos hanapin mo yung maliit na value ng f theta. Yun ang isusubstitute mo dun sa wala pa. Equation natin. Sa design equation. Okay? So net belt pull, tandaan nyo yung term na yan, and the power transmitted by the belt. If the smaller pulley is driving clockwise, so wait, naulit lang. Yan. Okay. So, mas may elements nyo, di ba? If the smaller pulley is driving clockwise, yan, the force F1 on the approaching belt, yan, is greater than the F2 on the receding side or slack side kasi dito lululus siya. So, mahina yung force dito. This force produces the resisting torque. So, F1 minus F2 times Rs is equal to Ts. The difference of the forces F1 minus F2 is called the net belt pull. Okay? So, ito yung figure 15. The driver torque on the large driven pulley is F1 minus F2 times R L is equal to TL. The net belt for all torque is computed from the horsepower equation. This is F1 minus F2 is equal to F. And horsepower is equal to FPM over 33,000. This is in feet per minute. And the input, this is pounds. So naman, F times PS is equal to over 550. This is feet per second. Also, horsepower is equal to TN divided by 63,000, where T is equal to N pound in N, RPM applied to the same pulley. Okay. So, kaya torque niya, so yung product ng torque and N equal. So, wait, natuloy na muna video. Okay, take note, So, torque are different. The product of torque and speed, kasi yung speed different than constant. Next, the capacity of flat belt. Ito na yung belt equation. So, where F1 is the maximum tension, it has been the custom in flat belt design to let F sub 1 is equal to sigma A is equal to sigma PT, where sigma is the design stress found to give good design. So, ito yung equation niya, F sub 1 minus F sub 2 is equal to BT times sigma minus 12 times rho times BS squared over 32.2 times EF theta minus 1 over EF theta. Ito yung binabanggit ko kanina, EF theta. Kung ano yung maliit sa dalawang pulley, yun yung gagamitin mo dito. Where BS is the belt speed in feet per second, rho is the 0.035 pound per cubic inch for leather, and rho is equal to 0.045 cubic inch for flat rubber building. Also, F1 minus K over F2 minus K is equal to EF theta, where K is equal to 12, rho BT, B sub S squared over 32.2. Ito yung typical force. Basa mo sa elements niya. B is the width ng belt across this paper. And T is yung thickness ng belt. So, next is the initial tension. Ano yung initial tension? Pagkasalpak na salpak mo lang sa pulley, so ikaw na siya agad na tension. So, in order to transmit power, the belt must have some initial tension or tension at rest. Taylor's recommendation is 71 pounds per inch of width. The tighter the tension, the more power can be transmitted without excessive splitting. Initial tension may be so low that the belt will not transmit its power. As the initial tension is increased, the value of tight tension F1 also increases. It not only becomes damaging to belt, but since F1 plus F2, a bending force on the shaft also increases. The operating conditions may become dangerous for the shaft and bearing. A relation F1 over F2 is often assumed for design purposes. Say F1 over F2 is equal to 3 with theta as 180 degrees. Initial tension neglecting centrifugal tension is F sub 1 is equal to F sub 1 over F sub 2 over 2 average. Initial tension considering centrifugal tension is F sub 1 is equal to F sub 1 plus F sub 2 times 2 plus 12 times rho BT B sub S squared over 32.2 all over 2, or F1 plus F2 plus 2 times NB squared all over 2. And plug phase, the belt material is not perfectly elastic. So therefore, the sum of tensions T1 and T2 when the belt is transmitting power is always greater than twice the initial tension. According to C.J. Bart, the relation between T sub O and T sub 1 and T sub 2 is given by, this is F sub O is equal to square root of F sub O is equal to F sub I plus square root of F sub 2. Wait na. So, ito. Pag-change ko lang yung T sa F. So, this is now the initial tension. Next, the rated capacity of leader belts. So, pag mag-base ka sa catalog, for sure, ito yung sample noon. Ito rin yung ngayon, meron pa rin ganitong mga format without using that belt equation. A simple design procedure using weighting tables and experience factor will give good answers to many problems. Say those of table 4 and table 5. Like the table 4 is yet rated those power per inch width cylinder belts. Meron tayong single ply, double ply, triple ply, meron sa mga thickness for medium and heavy, light, medium. Belt speed andito. Andito yung factor mo. Yung rated those power per inch. Suppose, minimum pulley diameter andito. So, nagabot yung lumit dyan. Factors, andito may mga factors na pabagitin mamaya. So, interpolations may be made between the speeds given with experience factors of table part applied as follows. Horsepower is equal to horsepower per inch, table 4, times B times C sub M times C sub P times CF1, CF2, which is the nominal horsepower that the belt is to transmit, or the nameplate horsepower for an electric motor. And B in inches is the belt width. Cm is the correction factor for the type of drive except for electric motor, which is 1. So, ito yung mga drive niya. Squirrel cage, 0.67, 0.5. Yan. C sub P is the correction factor for the size of the smallest pulley. The smaller the pulley, the greater is the pressure. So, C sub P. Ano yung size ng smaller pulley mo? Hanapin mo dito. Yan ang factor. Huwag ka lang mag-less dito sa minimum. So, C sub F is the correction factor for the environmental conditions, and more than one of these factors may be applied. Kaya nga, may pa-product na yan. Thus, a vertical drive in a dusty atmosphere and subjected to shock load would correspond to a total factor of C sub F equal to 0.83 times 0.74 times 0.71. Ito, di ba? Vertical drive. So, ito, vertical drive is 0.83, dusty atmosphere, 0.74, shock load, 0.71. Hindi naman sinabing jerky, so pero na, magkasabay na siya na shock load. Kaya yan, i-multiply mo yung product na yan. Yung binanggit. Pag may binanggit lang, pag wala, problem solving tayo. Other deviation from the cerebral practice that should be considered include abnormally short center distance and tight side top. The life expectancy of belts selected in accordance with this rating should be summed to 5 to 7 years. Observed at the bottom of the table 4, these smaller pulleys are permissible at the lower speed, but the belt does not bend as often. The strength of the belt joint is not considered in this design procedure. For leather belting, mount the hair or grain side next to the pulley, because the flesh side is tougher and can stand better stretching it gets on the outside. Okay, rubber belting. Rubber belting. Rubber belts are made in layers like 3 to 12 cold plies of canvas duct impregnated with rubber, which is later vulcanized. A 6-ply rubber belt has 6 layers of duct of about 32 ounce weight. So iba to sa didiscusan kanina. Neoprene wells or neoprene cover less susceptible to damage by oil are available. Since the belts are preferably endless, stock size should be, of course, with your set. For pedagogical purposes, let me vary from 1/4 inch to 2 inch, width by 1/2 to 5 inch, by 1 inch to 10 inches, by 2 inch to 24 inches. Ibig sabihin, more than 10, to 24 inches, 2 inches ang increment mo. Okay? That is 12, 14, 16, 18, 20, 22, 24. Then minimum recommended pulley diameter are for 3 ply, 3 inches, for 4 ply, 5 inches, for 5 ply, 7 inches, 6 ply, 10 inches, 7 ply, 14 inches, 8 ply, 18 inches, 9 ply, 22 inches. So, ayan. Kaya nga, susunod tayo sa guidelines. Okay? Huwag sa sarili. Okay? According to Goodrich Company, the permissible belt net belt pull is 13.75 pounds per ply per inch width, which gives a simple means for quick estimation here as F sub 1 minus F sub 2 is 13.75 BNP or horsepower is equal to P sub M N sub P over 2 cosine 400. From either of this equation, compute the width of belt P for N sub P plies. Number of plies yan. Correction should be made for other than smooth service and for arcs of contact other than 180 degrees. So choose the arc of contact factor K sub theta as follows. Like this one, for theta as 220, meron tayong K theta as 1.30. Rubber belts with cord construction have a higher capacity than those with fabric ply construction. So rubber belts should be mounted with an initial tension of 15 to 20 pounds per each ply, which is approximated if the belt is 1 inch per foot of belt leg shorter than distinctive measurement around the pulleys. Next is flat belts, drives for non-parallel shaft. Diba? Sa machine elements na namin pinakita doon. Belts connected shall do not have to be parallel, but the law of belting must be satisfied. To wit, the law of belting is the approaching side must approach the pulley in a direction perpendicular to the pulley's axis. So this is from your machine elements to red. Example. Sample number 1. 2 pulleys, one for 50 mm diameter and other 200 mm diameter on parallel shaft 1.97 meter apart are connected by crossbelt. Crossbelt tayo. Find the length of the belt required in the angle of contact between the belt and its pulley. Isa lang yan. Angle of contact, si crossbelt. What pulley can be transmitted? What power? Pulley. What power can be transmitted by the belt when the larger pulley rotates 200 RPM? If the maximum permissible tension in the belt is 1 kilonewton and the coefficient of friction between the belt and pulley is 0.25. So given, so ito yan, D sub 1 as 200 mm. Check nyo lang yung figure nun sa cross belt or 0.2 meters. D sub 2 is 450 mm or 0.45 meters. C is 1.95. N sub 2 is equal to 200 RPM. F sub 1 is 1 kilonewton or 1,000 newton. F is 0.25. Required is the length of belt, letter B, angle of contact, letter C, power transmitted. Solutions, letter A, for the length of belt, the cross belt is L is equal to approximately 2C plus 1.57 times D2 plus D1 plus D2 plus D1 is squared over 4C. Substitute values, L is equal to 2 times 1.95 plus 1.57 times 0.45 plus 0.2 plus ito naman, 0.45 plus 0.2 squared over 4 over 1.95 is 4.975 meters. The answer mo, letter A. Letter B, the angle of contact is theta is equal to 5 plus 2 times arc sine of r plus n over c in radians or 5 plus 2 times arc sine of d2 plus d1 over 2c. So may arc sine pa rin. So substitute values, 5 plus 2 times arc sine of i-close mo yan sa parenthesis, i-buong yan, 0.45 plus 0.2 over 0.95. Arc sine yan is equal to 3.477 radians. Multiply mo ng 180 over pi, that is in degrees. See, the power transmitted in kilowatt. F sub 1 minus F sub 2 is equal to B T times sigma minus 12 rho V sub is squared over 2.2 times E F theta minus 1 over E F theta. F, or this is approximately as F1 minus F2 approximately F1 times E F theta minus 1 over E F theta, but we're not approximate kasi wala tayong stress. Walang materials, walang walang materials tayo, di ba? So, sabihin ko, this is negligible. This one is negligible. So, kung walang binanggit na materials, so this is the zero, negligible mo yon, lalabas, magiging itong sigma BT is F1. So, F theta is equal to 0.25 times 3.477 is 0.8693. So, F1 minus F2 is equal to 1,000 times E is 0.8690 minus 1 over E is 0.8693 is 580.755. Dito nineglect natin ito. So, walang binanggit kong anong materials. Friction lang. So, F1 minus F2 is equal to 1,000. So, yeah. Power now is F1 minus F2 times B, or where B is equal to pi D2 and over 60 kasi yung given yung sa large Pulley. So pi times 0.45 times 200 over 60 is equal to 4.712 meters per second. So the power is equal to 580.755 and 4.712 times 1 kilowatt per 1,000 watts is 2.731. 77 kilowatts. So this is now your answer. Take note, index lang to. Pero importanteng kasama to kung may given kang materials ng rubber. Tapos, yung velocity is the same sa larger pulley saka smaller pulley. Now, example naman sa rated capacity of feeder belts. So, a squirrel cage line starting motor is rated at 30 horsepower at 1750 RPM and delivers its power to a horizontal flat leather belt located in a dusty atmosphere. The motor pulley is 10 inches diameter. What width of medium double ply belt is needed? Given, so 30 horsepower, okay, flat leather belt, medium double ply belt, motor pulley is 10 inches required, width of medium double ply belt. Solution. So belt speed is P sub m is equal to pi t and is equal to pi times 10 over 12, that's 1750 or 4580 feet per minute. Corresponding to this speed and to medium double ply belt, we get 11.97, say 12 horsepower per inch from table 4. So, okay to, malapit na to. 11.5, pwede gawin 12. 11.97 to. Kung nag-ano ka pang usog ka pang isa, so that is 12 na. So, pag 11.8, wag. Ito. Medium ply. Flat leather belt, medium double ply belt. Yan, medium ply. Hanapin mo yung 4,000. So, in-interpolate mo dito. Yan, dito sa lalabas. So, mga ko mo, minimum, pasok sa minimum diameter. Sa mga factor, andito table 5. Yan. CM 0.5, CP 0.7, and CF is 0.74. Ano sinabi dyan? Horizontal. So, 0.5. Hindi ko nilagay doon. Pulley size. 0.7. C sub P yun. C sub P is 0.7. C sub M is 0.5. Square cage line starting. Ayan, di ba? Squirrel cage line starting motor. So, 0.5 yan. So, C sub P is 0.7. Binanggit lang dito is dusty atmosphere. So, 0.74 lang. So, P50 value, si HP is equal to horsepower per inch, stable 4. So, okay itong 12 na runoff. Kung sa 2 significant figures, tapasok siya. Sa 3, significant pasok pa rin siya. 27, obviously 12 na yan. Kung 11.87, malayo. This is 30 is equal to 12B times 0.5 times 0.7 times 0.74. B is equal to 9.65. So use standard size of 10 inches belt. Okay, alam mo 9.65 ang orderon mo. Okay, so standard, sigurado may standard yun na 10 inches. So this is the end of this topic.